Okay, so we're gonna do number two in the homework. Is that okay?
Sure.
Okay, so um, 2A, I think is like a relatively straightforward question asking the, oh, hey Maria. Oh, and Thomas.
Hey, Oliver, I was muted.
So for number 46, so the likelihood that the tire failed at 20,000, I was showing you my picture earlier. If the average is 26, and this is 20,000, we're looking for the area.
Yeah.
The probability that we hit the area curve, which is out to 11.5%, which feels like a reasonable answer.
Yes.
I appreciate that confirmation. And then for part B, I think we were struggling a little bit with how to approach it, thinking about expected value or lack thereof. Our first approach was to say something like the maximum likelihood that the manufacturer has to pay is 11.5%. It is like incrementally less likely that the manufacturer has to pay out for every mile below 20,000 and a 0% chance they have to pay out above 20,000. So 11.5%, there's the expected value of the cost of the manufacturer is 11.5% times 400, which is $46. But the expected revenue is $200 every single time. And so the difference of that is $154, which is effectively a guaranteed profit. Is that the right way to think about the problem?
So the part B, right?
Yeah.
B. So I think it's pretty similar to the part A of the first problem. Like as long as you're gonna sell this insurance to only one person, you don't have to consider very complicated probability. You just consider what is the probability of less than 20,000 and greater than 20,000 for that one person, that one set of tires, right?
Okay. So in a one chance, I see.
Yeah. Because there's two, there are only two possible outcomes.
Yes,
the tire
fails
before 20,000 miles or after 20,000 miles. Only there's two possible outcomes for one person, right? So I'm only considering these two outcomes, and you have already calculated the probability in part A, right? And I'm the manufacturer. I am only considering two possible outcomes, and among those two possible outcomes, I lose money in one possible outcome, and I earn money for another possible outcome. So it's just a two choice problem. So
okay.
Yeah.
That makes sense to me. I think you've explained enough that.
So the idea that it's 1 minus the probability of A
Yeah.
is the right direction.
I think,
Yeah. I mean, probably you guys think about it in a more complex way, but it's for if there are more people, there are multiple people, you're gonna use a central limit theorem or use a z-score or something. But for one person, it's two possible outcomes. You don't have to think about it in a complicated way.
Okay. So then conveniently question C does ask about multiple, right? As opposed to
500.
just one. Yeah, 500. I think it's pretty clear on how to use the z-score in the setup for question A. I think it's less clear how to use it for question C. Again, I would take an expected value.
Oliver, are you on question 2?
Yeah, we're on question. We started with 2, so
That's kind of my same question too. those two different formulas, like the central limit theorem versus the z-score, and like when to use it. Like, how do you know when to use it? What's the difference between, you know, question 1 and 2? Because I noticed that we used those two different ones for each.
So what's your progress so far? Like,
I mean, I already I pretty much have it, but I'm still confused as to why or how or when to use the central limit theorem.
okay.
Like when you have, what makes it different from just using the z-score formula.
Okay. So basically, they are pretty much the same. Like when the assumption of central limit theorem holds, then you can use the z-score formula and use the z-score table to visualize the probability on that table.
Okay, I need to show you the two different formulas I'm looking at.
There's a formula where in the denominator you divide by the square root of n, and then there's one where there isn't. So when do you use each, and what's kind of the difference between the two?
I mean, for the z-score, the formula is x minus mu divided by standard deviation, right? I can show you that formula. Just a second. Getting it. Oh, here it is. Okay, can you see this slide?
Yep.
So this is the standard normal distribution. Yeah. And it holds for the binomial models. So for both the two questions here, I guess the professor also gives like examples of toads and coins in the class. Toads and coins is also a binomial models. Here in the home assignments, it's all binomial models because there's only two outcomes in short, success or failure, and each outcome has a constant probability, right? That's a binomial model. And you would just do exactly the same thing as you did in the home, like in home assignment, the question number 1, and also in the class examples. So for a binomial model, you can compute the mu, the expected value, and the sigma, the standard deviation, using the formula here. You don't have to know how you get those formula. It's pretty complicated using some calculus method. Here is NP and NPQ. This is how you get the expected value and the standard deviation. Here NPQ is a variance, and you take the square root, you get the standard deviation, right?
Yeah.
Every time you want to use that z-score formula, you need to know 3 things. What is x? What is mu? What is standard deviation? And you already have to by using these 2 formulas, right? So in problem 2, first you should calculate what is NP and what is NPQ, right? For the part C of question number 2.
Right. So, I mean, here we don't use the central limit theory at all. Theorem.
Yeah, you can say so. We're using a z-score.
Okay. Sorry, Oliver, you can continue. Thank you.
Yep. So
No. I mean,
You're
Go.
good?
No, we were arriving right on time. So NPQ
Yep.
is the approach for how we think about Part C, with N being number of trials.
By the way, we'll also use this formula to complete the first problem, right? You can look at the first problem, I mean problem number 1, or the part A of problem number 2. But I guess like for part A of problem number 2, they just gave you the number. So you better like take a close look at the first problem, how you get the expected value and the standard deviation.
Yeah, I guess I haven't done the
100%
first problem, so that presents a challenge in looking back at it. So I can do that.
Wait, so
Because that's just
for part
circular.
3, so are we saying 500 instances times the probability of it failing times $400 plus 500 instances times the probability of it not failing times $200? Both of those are equal to, added together equals 0. So in this case, in part C, I was assuming at first that the probability of pass and fail was the same as part A, but it's not, right?
Oh, it's the same for A.
It's the same.
Yeah, you have just calculated. I think like Oliver said it's like 11% something, right?
Yeah.
The probability of failure. Yeah, that holds for the whole problem. The probability of failure is like 11% something.
But it's asking for the probability of a profit now.
Yep. Yep.
So the probability of profit is different than the probability of failure in A.
Yeah, but I don't understand how the probability of profit changes with the number of trials.
So I think like what you just like at first you said I'm not sure if that's what you mean, but I guess you are saying something like the manufacturer will always make a profit, right?
Well, I think the expected value is always a profit. Yes.
Okay, but that doesn't. So okay, so my expected value is a mean, right?
Yes.
Probably, for example, my expected profit is $100, but
It's
there's
not.
but
It's
there are
100.
variances. There's some turbulence between like that mean, right? So I'm still at risk of losing money, even though my expected value is positive, right?
That's true.
Right. I expect I can get an A, but if I screwed in final, I get a C, right? It's
Yeah.
possible. I'm still at risk of.
I'm not sure it's possible for you to get a C, but sure. So I think that I understand. What I don't understand is in the example that we've been given, or the question that we've been given, it feels like the same question twice, right? What's the probability of profit where n is equal to 1? What is the probability of profit where n is equal to 500? Why does the probability of profit change with n changing?
Okay, sure. So let's start with a more easy example, right? And I think it's covered in the class. So can you see the slide here?
Yes.
It's a toes and coin example, right? So basically, we are using that formula. We're using that z equals x minus mu divided by sigma. We're using that formula. But here it's like more straightforward. I'm just asking you. Here I have a binomial distribution with the mean equals to 500, so mu equals 500, and standard deviation equals to 15.81. I just tell you these two numbers. This is the mean and standard deviation of my binomial distribution. And then I just said directly to you, I want to find the probability of observing 470 to 630 heads out of 1,000 toes. So you know what is the value of x, right? The first x is 470, the second x is 530. So basically, when you use this z-score formula, the most important thing is you find that 3 parameters in that formula and you plug in the number.
And the 3 parameters are the
X, the mu, and the
X is the value I want to find. Mu is the mean of this binomial distribution. And sigma is the standard deviation of this binomial distribution.
so in this case, isn't the mean the expected value?
Or is
Yeah,
it
the mean is
26,000?
always the expected value. And you have the formula for that mean. Remember, for binomial distribution, the formula mean equals n times p.
Right. Well, yeah, which is again the expected value, which is our 11.51%, I think, times I guess is this the expected? We know the expected value for
So the mean changes from the 26,000 to the 55.55. Because we're talking about we're talking about a different.
Oh,
type
you're
of
right.
mean,
Yeah,
right?
yeah. So I keep getting caught up in the profit, but you're right. You're talking about
You're no longer talking about the mileage
you're
mean.
talking about the number of trials.
Yeah.
So your average failure is 58 failures. Is that right?
Well, would you use the same, because if you're doing 500 failures, right, and the probability that we had in part A was 0.1151, but that probability was based on trial, that was based on like something different, wasn't it?
no, it's just one instant.
Okay. Well, it's kind of
So like you are setting the trials, right? And the probability of a trial failing before 20,000 is 11.5%, right? And now you are setting 500 sets of tires. What do you expect? How many of tires would fail before running 20,000 miles?
That's crazy.
Well, it's the same amount,
It's 58.
58 failures out of 500
Yeah.
trials.
That would be 11.5%.
Like how do you calculate that?
Well, 500 times 11.5.
Yeah, so that is NP, right?
Yes.
Right. So instead of tossing 1,000 coins, now I'm selling 500 sets of tires. It's essentially the same thing. Tossing a coin, I have 2 possible outcomes, heads or tails. Selling tires, I also have 2 possible outcomes. It fails before 20,000 miles or it fails after it. So it's just it's the same binomial distribution with like different natural language, but it's binomial distribution.
Is it 500 times 200 and then 58 times 58 failures times how much do they pay?
That's the profit, though. We want to know the likelihood.
Yeah, but if 58 failures times 400 or whatever that is.
I did it earlier. It's 23,200, and 500 times 200 is 100,000. So your expected profit is 76,800. But that doesn't tell me. That doesn't tell me.
That doesn't tell you what's the variance of the profit, right?
Right.
You just have the expected profit. So now instead of, because we don't know what is the distribution of profit, You get that point? We only know the distribution of selling the tires.
So do we have to figure out where like profit and loss equal each other?
Yeah, exactly. That is like the slides here for 470 at 630. You need to find like how many tires you can accept them to fail. Here in this question, I'm accept finding 470 to 630 heads, but in the home assignments, you need to find how many sets of tires it's acceptable to fail to
I'm sorry,
make at least
acceptable or expect?
Acceptable. 'Cause
acceptable to be failing in order to make a profit.
But if like, I don't know the numbers, but if like 100 tires fail, they could still make a profit. If 200 tires fail, they don't make a profit anymore. So well, we have to find that point of inflection in where what's the max amount of tires that they can reimburse and still make a profit. Right?
I understand.
Yeah.
Nope, I think that's clear. Okay, we've dominated. Melanie and Thomas and Maria, sorry. Go ahead.
Oh, all good.
Like you will use the numbers in the question, like how many monies I earn by selling one set of tires and how many dollars I need to give to a customer, I think, if the tire fails before 20,000 miles, and do some algebra. Maybe you will solve an equation to get what is the break-even point of not making money and also not losing money.
So I think a question I have is when do you know that you need to, when you get the Z-score, that you're doing 1 minus the Z-score rather than just getting the, so like in 1B, for my final, like at towards the end, I did 1 minus the Z-score. But then I think it was in 2A, I just used the Z-score that I found. So how do you kind of know when you're doing 1 minus the Z-score and when you're just taking the Z-score as the answer?
Okay, so maybe I need to write that down. You can see the slide now.
Yes.
So basically Z equals to what? Oh, X, it's ugly handwriting. X minus mu divided by the standard deviation, right? So how to determine? So first, this is a score. This is a number. This you can calculate it. This you will finally get a number, and you find that number in the z-score table. right? The z-score table, they'll give you like a distribution. This is a z distribution, and sometimes it depends. They will like shaded some area as your z-score table. And at this number, you have this z-score, and in the table, you can see what is, for example, when z equals 2, they just give you a number. Okay, they just give you another number. What does that mean, right? So basically, if I want to find, it depends on what you want to find. If you want to find the area on the right, I mean the white area in this distribution, then you should use 1 minus n. Because in the table, the n always gives you the area of the shaded place. Right, so it depends. If you want to find the probability of your number less or equals to z, you use this n directly, this little n directly, because that is the probability of the shaded area. And you know the whole area equals to 1, so the area just means probability. So in the second, for example, I take the part A of the second question, for example, you will find, like, I guess it asks you to find the probability of the tire fails before 20,000 miles, right? So I'm gonna find the probability of x less than 20,000. I'm finding this probability. So first, I plug in x equals 20,000 in this formula, and I can get a capital N, which I will plug into this diagram and to the z table to find what is the probability. And this probability, like if the diagram is like shaded in the left, and this probability is the probability of z less or of x less or equal to this particular z number, and it just fits in this problem because I'm trying to find what is the x less than 20,000.
Thank you. I think that helps.
Yeah.
Thanks.
Yeah, it depends. So sometimes you will use the white area, sometimes you use the shaded area. Whenever you calculate the z number, you will like think back, what should I find about x? It's less than particular number or greater than particular number. And in part A of the question 2, I'm finding x less than 20,000 miles. So I use what is on the left of the score.
We have a follow-up, Victor. So I think we've made good progress in setting up the formula for the z-score on 2C. Where we're struggling is how to derive sigma. Yeah. So like, other than being given sigma, how do you calculate sigma in
You have a
general?
formula here. You have a formula here. NPQ, remember? You can see the slide here.
I can't see this. I'm seeing home assignment 4
Okay.
with a Picasso-esque drawing on the bottom half.
Sure, stop
He's a
sharing-
legend.
sharing.
Picasso's a legend. Don't worry about it. This guy's own museum.
Can you see it now?
Yeah. Okay. Oh, okay. So sigma squared is equal to NPQ. So sigma is equal to, all right, I think I understand now.
Times 311. Right.
And P and Q are the inverse of each other, right?
Yeah, they add up to 1.
Okay, and N is,
So it's n times 1?
no. They add up to
The
1.
product isn't 1.
Yeah, I made a mistake.
No.
The product.
There is a.
No, that makes sense. And then N is the number of trials.
That'd be 500, right?
What is N?
You use that in NP, right? You just calculate that
Sorry, what?
Is N 250 or is N 500?
500.
Thanks, Victor.
That is the number of trials. That's what I was trying to get
N
at.
is the number of try.
Yeah.
P is the probability.
P is the problem.
Okay, thank you.
It's still at 11.5%.
Yeah.
Oh, yeah.
It goes on for the whole problem.
Times 0.8849.
All right, Victor, we're signing off. Thank you for your help.
Sure.
Have a-
Thank you.
Have a wonderful evening.
Have a wonderful night.
Do I want to do question 1?
Thanks, Victor.
Yeah,
Very
If
helpful.
you have any question, just you can stay here or you can like send me an email.
Perfect. Thank you so much for having this tonight.
Sure.
Bye. Have a good one.
Bye. Have a good one.
All right, Victor. So I guess we were just talking about for 2C there, getting the standard deviation and looping N into it. But so then, if we're just looking at NPQ, which is the the 11% times the 88%,
Yep.
and then times the 500, right?
Yes.
But how does I guess does the 5,000 standard deviation not really play a part anymore? Is that the standard deviation of a single trial, and that's what got us our P and Q, so we don't need the 5,000 anymore?
What is 5,000?
The standard deviation.
Okay, sure, I got you. So that standard deviation is the fluctuation of the tire's failing time, right? But now I'm finding the standard deviation of the binomial distribution with 500 trials, and the probability of success is like 88.5% something, and the probability of failing is 11.5 something %. So it's different. The standard deviation 5,000, it's individual standard deviation for one set of tires. And now I'm trying to find the standard deviation of the whole distribution. I have 500 sets of tires. So it's different.
Okay, so once we have that standard deviation, then let's see. So the manufacturer sells 500 tires. What's the probability they earn a profit after paying for the replacements? Okay, so let's see. Trying to think of what I'm looking for in top of the Z-score. That hold on. I guess is this still binomial where it's a profit if it doesn't fail and it's not a profit if it does fail? So it's similar to the first one where we're looking at, or no, I guess it's similar to the second one. So we're looking at the probability that it's greater than 20,000 miles, right?
Yes.
Okay, so it's a similar setup to B, except we have a different standard deviation now, essentially, in the denominator.
For 2b, it's
Yeah.
not similar to 2b.
Is it?
In 2b,
Yeah, I guess
you're not using the z-score, right?
Sorry?
In 2b, right? You're talking about 2b. In 2b, I mean, we are not using the z-score. We're not using the z-table because I'm only sell the tires to one person. I only have two possible outcomes, fail or not fail. And whenever that tire doesn't fail, I gain a profit, right?
Right. So yeah, so it's 1 minus what we have in 2A.
Yeah.
Right. Yeah. It gets in the same way. Yep.
Yeah.
Okay. Okay. So I guess it's similar in that way that it's you're looking at. I guess it's 1 minus. Yeah, the 20,000 minus the 26,000, but now we just have over this smaller denominator instead of the 5,000. Okay, I think that makes sense to me.
No, we're not using the 20,000, 26,000 in this question.
Hold on. Let's see. Manufacturer sells 500.
Because 20,000, 26,000, that doesn't give me any information. That doesn't apply to any distribution. It's just a number. I know, like when I sell every set of tire, the expected mean is 26,000, but I don't know what distribution it belongs. So it doesn't give me enough information. But I do know that when I sell it to 500 people, right? That is the total amount I'm selling. And there's two possible outcomes: fail before 20,000 miles or fail after 20,000 miles. There's two possible outcomes. And the probability is all the same because all the tires are independent. So the probability is 11.5% throughout every tires.
Yep.
And that gives me a binomial distribution, right? Remember what is binomial distribution? Like tossing a coin, that example you did in the class, you toss 1,000 times. That is comparable with here. I'm selling to 500 people. And tossing a coin also have two possible outcomes, heads or tail. And the probability stays all the same. 1/3, one half, right? One half.
Yep.
Here we have exactly the same setup, right? I'm selling to 500 people, two possible outcomes, fail or not fail, but the probability is instead of one half, it's like 11.5%, but it's still
Right.
a very standard binomial distribution. So I'm using the z-score. Right, so now I have this binomial distribution. What is its expected value? What is its standard deviation? You just like compare that to the tossing coin example. How did you calculate the expected value and the standard deviation when you toss like 1,000 coins?
All right. So I guess the standard deviation is quickly. So I have that. So that's I think 7.135. Let's go with 714. I guess.
Yep.
And then the expected value, I guess, is 500 times the 11.5%, right?
Yep.
So that is 57.5 and change. Okay, but then.
So you already have two parameters in that formula, right? In that formula, you also have to find what is x, right? That is a bit tricky in this problem because during the class, the professor just gave you the x. They said like what is the probability of finding more than 400 heads out of 1,000. toes. So you know, okay, here the x equals 400. But in this home assignment, they didn't like tell you directly what is the number you hope to find. But you should, but they like tell you implicitly. They said, I have to make a profit, and they gave you like the number of how much money you gained by selling one set of tires, and how much money you lose if it fails before 20,000 miles. So you should play around with those numbers to get what is the break even number that I can accept, and I still make a tiny bit of profit.
Okay,
You're
so
selling
we're, okay.
500. Yeah, you're selling 500. You don't want like 300 of tires fail, right? Because then you will lose money. But now you should find a break-even situation. Like I'm accept how many number of tires to fail, because I'm still getting a little bit money.
Okay, so we're using the 200 profit if it doesn't fail, and I guess the minus 200 profit if it does fail, and we're looking. So we're using that to solve to get our x of our break even point. So it's the 200 profit times that 88% probability, the minus 200 times that 11.5% probability,
So
right?
now you're not using that probability. You just need the number, like how many number of tires can fail in order to still make some profit.
Okay, sorry. So I was not using that 500 count then. So if we're selling 500, how many fail and how many don't fail, then okay, I gotcha.
Yeah. Yeah. They'll like just tell you like what is the number we might want to find, but in an explicit way. They don't they are not telling you like I'm gonna find 400 heads out of 1,000 tails, but they just tell you for example, in the toes and coin example, they tell you how I want to get 2 times more heads than the tails. What is the probability? It's pretty similar to this question. Like you need to solve a simple equation, something, to find that x.
Okay. Yep, I think I got it.
Yeah.
All right. I think I'm all set then. And I'll at least on 2, and I'll take a look at 1, and if anything else, I'll look back at some of the recordings.
Sure.
All right. Thank you, Victor. Appreciate it.
I think in the last recording, the Sunday morning one, like I went over all 2 questions. So maybe you can look at that one.
Okay, will do.
Sure.
All right. Thank you. Appreciate it.
Bye. Have a good
All
night.
right. Bye. You too.